So today we're going to talk about bivariate analysis. And bivariate analysis is when you look at the relationship between two variables. Or another way of looking at it is, how does one variable affect another? Okay? There are a couple things you need to understand with a bivariate analysis. You can do a bivariate analysis with any variable measured at any level. So any variable measured at any level, you can run a bivariate analysis. Okay. Depending on what levels of measurement you have, you will run certain analysis. So at the nominal and ordinal level, you will run a crosstabulation. And for interval or ratio, you will run a correlation. Now, that is the rules. Okay. Now, that's not to say that I've seen crosstabs with interval ratio level data, although you shouldn't run it. I've seen it, and I most certainly have seen nominal ordinal level data run using correlations, and that's the most likely violation that you will see of the rules. Just because correlations are easy to interpret, okay, or easier to interpret than crosstabs. Although crosstabs give you a little bit more information than correlations, okay. So bivariates are also called measures of associations. Or bivariate analysis, what you get is a measure of association, and the exact statistics for those measures of association are lambda, gamma, and Pearson's R. Okay, and so what you want to do is look at typically how you decide what you run, either correlation or crosstab, and what type of measure of association you will request is based on, a good rule of thumb is based on your dependent variable. Okay. What level of measurement is that dependent variable? And that will help determine what measure of association you will request. To get the lambda and gamma, you will run a crosstab, and the Pearson's R, you'll run a correlation. So crosstabulation for this guy. Same for this guy. And then for Pearson's R, you would do the correlation. Okay, so today, or for the purpose of these lectures, we'll talk about interpreting. We'll talk about how to, well, I've already shown you in your videos how to retrieve these analyses. How to retrieve these analyses, you will look at the lectures on how to construct tables, APA tables using bivariate analysis, and then for how to interpret is what these lectures will be on. Okay, how to interpret. All right. So given that, let me go show you the first thing. So this is a crosstab. So I ran this earlier. And so I wanted to show you, first of all, we're going to talk about how to read the tables, and then what information is needed in the tables. All right, so how to get it, you definitely want to look at that lecture on how to create APA tables for bivariate analysis, crosstabs, to understand how I retrieve this table. Now, when you do get the tables, you get this case processing summary at the top. That's this guy right here. And this information basically says how many valid cases were in the analysis for this particular variable, and then how many was for each one of these runs. And for the first one, it's looking at gang association, and well, it was grade, but I took that out. So we are actually only looking at two. That's gang association and sex, which you'll see here, which is gender, and then gang association and the county, if they were in the county or out of the county. All right, and this is data, gang data that was, or data that was collected in the school district in North Carolina to look at students' gang association and what factors affected that gang association, only among Latinos, though. Okay, so all of this data is about Latino school kids in a particular county in North Carolina. All right, so one thing I want to show you is how to read the tables. All right, so you have, this is what's referred to as a contingency table. And your book talks about contingency tables. All right, I want to give you a couple of notes on the contingency table. So you need to know what a contingency table is. And the contingency table is basically the values of one variable are contingent on the values of another variable. Okay, and so let's go back to our example. This contingency table, how do you read this? So the values of this variable are contingent upon the values of this variable. All right, and so this variable here is gang association, and then this variable over here is gender or sex. All right, now for the most part, the protocol is that your dependent variable will be located in what's referred to as the rows. All right, and these are considered rows because you read across this way. All right, you read along this horizontal line here, and then this would be traditionally your independent variable along your going down your columns. Okay, so gender is considered the independent variable because it's located in the columns, and gang association would be your dependent variable because it's located in the rows. All right, and for all of the tables that you will get with me, that's how you should read it. Okay, your dependent variable would be here, your independent variable would be here. If you didn't know where your independent variable is located and where your dependent variable is located, typically what you want to do is find those 100%. All right, these are the 100% that you want to look for, and wherever they are located, you can be, I don't know, 90% sure that that's where your independent variable is located. Okay, and so our 100% are located in the bottom row of our columns, and so then you would assume then that sex or gender would then be our independent variable, which then would make gang association your dependent variable. Okay, so follow those 100%, and that will show you that that's your independent variable, and the opposite of that would be your dependent variable. Okay, the other thing that you need to know looking at this table is that you have several different statistics here. You have your chi-square, and you have your measures of association. The ones that we're going to be concerned with are lambda, gamma, and Pearson's R. And determining which one of those we will interpret. You don't interpret them all, you interpret one of those, and I'll show you how to do that. Okay. Now, looking at our contingency table, this is the thing that you were shown in the lecture on how to use this data, how to plot these in your in a Word document. And so looking at this contingency table, what you want to know is the relationship between gang association and sex. That's our hypothesis. Is that statistically significant? In other words, the sex, being whatever gender you are, does that affect potentially whether or not you're associated with a gang? All right, so that's the hypothesis. Gang association has a relationship with gender. Okay? All right. All right. And speaking about hypothesis, let's go back to our whiteboard. All right. So before you get started, you always want to hypothesize a relationship. Hypothesize a relationship. And there's two ways to hypothesize. You have your null hypothesis and you have your research hypothesis. Okay? The null hypothesis always states that there is no relationship between two variables. Okay, so looking at gang association gender, you would first of all show you how to write that. That would be H01, and you would subscript these by highlighting them. And in my Mac computer, it's easy to figure out how to do this. You highlight, alright, and then you come up here and click the subscript. Now, if you were in a PC, you would highlight, click on font, and then open up font because it's a font function, and then click on superscript, and that would give you your how you would do that. Okay, so H01. So looking at gang association and sex, you would basically say there is no relationship between gang association and gender or sex. Okay, and I'm just going to cut and paste this, or copy and paste it, because the research hypothesis is similar, but nonetheless different. Okay, the research hypothesis would be stated with an undo that. Will be stated with an H1, and you would say there is a relationship between gang association gender. Okay, so that's the difference between null hypothesis and a research hypothesis. So a research hypothesis always states there is a relationship between two variables. Okay. All right. So that's how you state hypothesis. So gang association has a relationship with gender would be give you a second to think about it, a research or null hypothesis. It would be a research hypothesis and not the null hypothesis because it's stated in the positive. I'm trying to highlight this guy right here so I can subscript it. Alright, and so that's our hypothesis, and we want to find out, can we say that yes, indeed, this relationship does exist. Alright, so the first thing is in the Crosstab, there's several things that you can ask for, and I've asked for our measure of association, which will fall under directional measures as well as symmetric measures, because I've asked for the lambda, which is falls under that directional measure, which I don't know why, and then gamma and Pearson's R falls under symmetric measures, and I'll explain why I don't know why lambda falls under directional measures. Alright, the chi-square test is what's referred to as an inferential statistic. So let me go back to our blackboard. So in the crosstab, in a cross tabulation, you get your measure of association, and I've asked for all three. And you also get the chi-square, which is our inferential statistic. And you remember from test 1 that inferential statistics allows you to infer what you found in a sample to a population statistic. Okay, so our measure of association would then be our sample statistic. In other words, it only looks at whether or not a relationship exists in a sample. Okay. Now, what level of measurement do we have with our variables here? We have no association, 1, 0, 1, and 2, and then gender, which is a 0, 1. All right. So if you recall, gender should be, or you should note that that is a nominal level measurement, and gang association here would be a ordinal level measure because it goes from no association up to thought about it and joined. Okay, you might even argue, no, that would be an ordinal level. I was going to say you might argue a nominal, but that would be ordinal. Okay, so in the case of gang association and gender, we have a mixed bag here. All right, we have both an ordinal level measure and a nominal level measure. And if you recall, just a few minutes ago, I told you that you would typically look at the measure of association that follows the dependent variable. Whatever level of measurement the dependent variable is, then that's the measure of association that you will use. And so in this case of gang association being ordinal, and and gender or sex being nominal, our measure of association that we will use would be gamma. Okay, and I forgot to put up here some additional notes. So lambda would be used with nominal. I think I said it, but I didn't write it. Nominal level measures. Gamma would be ordinal level measures, and then Pearson's R would be interval or ratio level measures. Okay. The other thing that you need to know about these measures of association is that lambda has values. Their values go from 0 to 1. Okay, and the closer you get to 1, the stronger the relationship is. Okay. All right, and gamma and Pearson's R go from a -1 to 1. All right, and that is because they can actually show direction. All right, values go from -1 and that's because they can show direction. Whereas lambda can't show direction, because if you note, the characteristics of a nominal level measure is that it has no rank order. And because it has no rank order, meaning that there's no difference between one category over the other, it can't show direction. All right. Although with gamma and Pearson's R, there is a rank order, or the category that's below is different in value or quality than the category above it. Okay, and so they can show direction. So their values go from -1 to 1, and the closer you get to -1 or 1, the stronger the association is. Okay, and what I want you to note is that if it's a negative number, negative numbers do not mean that the interpretation is negative. Okay, it doesn't, in other words, a negative doesn't imply the quality of the relationship in terms of they don't like you or they didn't find something. It doesn't do that. It simply only shows direction in terms of how you interpret the contingency table that you have. Okay, and I will explain that as we go along. Okay, so negative numbers do not mean that the interpretation is negative, and I will give you an example of that. Okay. Um, So because gang associations ordinal and gender is nominal, then what that means is that we should use the measure of association that is used for, that is gamma, all right, because it's used for ordinal. And remember I said that you, depending on the levels of measurement, you want to follow that dependent variable. So our dependent variable is gamma or ordinal, so we will use gamma as our measure of association. Okay. All right, so given that, I wanted to show you how you would go about interpreting this data. And I'm going to actually do that inside of this document here. So I'm just going to tab down. Okay, so in terms of interpretation, increase this font size. Oh, wow, that's so. Okay, there's elements that you want to include here, and the first line of your interpretation will include um, um, identifying the dependent and independent variable, identifying the independent and dependent variables, strength, and direction if needed. Okay. 2 would be whether or not would be looking at the sample statistic. 3 would then look at the chi-square statistic or the inferential statistic, and then your overall interpretation of the data. Okay. All right. One other thing that I want to give you in terms of preliminary information is looking at levels of statistical significance. All right, statistical significance referred to as your confidence levels. Looking at confidence levels and p-values. All right. Confidence level says how confident are you that what you find in your sample or in the population will actually exist. And so basically we have 3 confidence levels that we focus on: 95%, 99%, and then 99.9%. Okay, and those are coincide with p-values as well. So in this case, the p-value at the 95% would be 0.05. P-value for the 99.9 would be 0.01, and then the p-value for the 99.9% would be equal to 0.001. All right. All right, so how do you interpret confidence levels, or p-values rather, in terms of interpretation? If the p-value is equal to or below the 0.05, below 0.05, then the relationship is significant. Okay. Once you know that it is significant at least at the 95% confidence level, or p is equal to or below 0.05, the question becomes is how significant is it? Okay, and that is then you're required to then say if it's equal to 0.01 or below, but above a 0.001, then it's significant at the 99% confidence level. And if it's equal to 0.001 or below that, which the only thing below that is a 0.000, then it's significant at the 99.9% confidence level. Okay, so if it's at least equal to 0.05 or below that, then it's significant. The question then becomes is how significant is it? Okay. All right. So let's get back to the interpretation. The first thing in your interpretation is you want to identify the dependent and independent variables. I've told you how to do that in the contingency table, where the dependent variable and independent variable will be located. In this case, gang association and is our dependent variable, and sex is our independent variable. The next thing is how strong is that relationship. Now we know that we're going to be focusing on gamma because the dependent variable is ordinal and the independent variable is nominal. So gamma is our focus. All right. So given that gamma is 0.343, let me give you that information as well. So strength of the relationship. Okay. Anything that is, and people have different measures for these. You have to look in, particularly in your field of study, to know what good is. Anything around a 0.35, you would consider it a moderate relationship. All right. So the question becomes is then what is weak, and then what is strong. All right. So I will argue that anything in the low 20s, low 0.20s, and below, you can argue a weak relationship. And then anything, I will argue anything in the 0.4s and above, or let's just say 0.50 and above, you can argue a strong relationship. Okay. All right. So given that, in our example, we have a gamma value equal to 0.343, then we would call that a moderate relationship. So let me give you your words. All right. So in the interpretation of this first, in terms of the relationship between the dependent variable, gang association, and the independent variable, gender, the relationship shows a moderate positive association. Now, where did I get the positive from? Okay, the same number. If it's a negative number, it's a negative relationship. If it's a positive number, it's a positive relationship. In this case, it's a positive number. Okay. All right, that's a positive number, so it's a positive relationship. So in terms of the relationship between the dependent variable gang association and independent variable gender, the relationship shows a moderate positive association. Okay? Now, the p-value is here, where I've highlighted this. This is p is equal to 0.000. Now looking at our test over here, where would that fall? Where would that fall? It's below a 0.05, so we know it's at least significant. All right, 0.000 is below 0.05. So how significant is it? Well, it's actually even below a 0.001. So therefore, it is significant at the 99.9% confidence level, or p equal to 0.01. 0.001 rather. So the next line of our interpretation would read, the relationship is significant in the sample as gamma is significant. And then in parentheses you would write gamma is equal to 0.343. Remember, you always have to show your evidence at this point. Okay, everything that you say, we need proof, and p is equal to 0.000. All right. Now the chi-square. All right, I keep going back and forth, and that's because I can't keep forgetting that the stuff is up here. All right, so chi-square is our inferential statistic, and what you have to know in terms of chi-square are these things here. Chi-square minimum value is 0. Okay, but it has no maximum value. Alright, it can be as high as it is, alright, to infinity. Okay, chi-square is, like I said, we're using it as an inferential statistic. Its value, or its significance is affected by sample size. Okay, so what does that mean? That means that lambda, gamma, and Pearson's R are not affected by sample size, but if you have a large enough sample, chi-square will be significant all the time. Okay, a large enough sample will make chi-square significant. Okay, and so because of that, if your sample statistic is not significant and chi-square is, you still would not assume that that relationship exists. Okay, and that's because your sample statistic is not affected by sample size, but chi-square is. Okay, the other thing with chi-square is a little bit different, is your degrees of freedom should be reported. And the degrees of freedom are determined by, let me give you the formula, is R minus 1 times C minus 1 is equal to the DF. Okay, so the R is the row, and the C is the column. So what you do is you say, how many rows do I have? In this case, you have 3 rows, 1, 2, 3. And so that would be 3 minus 1 give you 2, and you have 2 columns. 2 minus 1 gives you 1. So you'll have 2 minus 1 is 2, which should give you degrees of freedom equal to 2, and it does. Okay. All right, and you can just go and do that math yourself over here. So you have 3 columns, 3 minus 1, and that's time. That gives you a value equal to 2. And then you have a column of 2 minus 1. And when you do the math on that, you'll get a degree of freedom equal to 2. Okay, which was what we got. Okay. Alright, so to interpret the chi-square, all you want to know is it statistically significant? So this is your chi-square value, and this is your degrees of freedom. and this is the p-value. The question is, all you want to know is that relationship, or is the chi-square significant? As long as your measure of association is significant, that is. Okay, and we found that our measure of association is significant, so now we want to interpret the chi-square. So what you say is the relationship between chi-square, between the dependent variable and the independent variable can be inferred to the population as chi-square is significant. And again, what is your evidence? Chi-square is equal to 25 point, I forget what it is, 25.700, and P is equal to 0.000. Alright, and then the last thing you want to do is do your overall interpretation, and that is and you have to understand how to read direction at this point. Okay, so we know that this is a positive relationship, so that means that you look at a high relationship or a low relationship. So high versus high, or let me put that in, low versus low. So what does that mean? You go up here to your contingency table and you match up the low values on your dependent variable, which this is a low value on the dependent variable, with the low value on your independent variable, and the 0 is the low value on our dependent variable. Or because it's positive, you can go low or high rather, because this would be high. The value 2 is the highest on the dependent variable, and the value 1 is the highest on the independent variable. So what you would do then is look at the relationship based on those numbers and say basically that in terms of gang association, females are more likely not to be associated with gangs, whereas in terms of the high, males are more likely to have thought about joining a gang and have actually joined the gang. Okay, and that would be your overall interpretation. All right, and whichever you choose is fine. You don't have to do both. Okay, so in terms of gang association, males are more likely to have thought about joining a gang, and indeed and in turn joined a gang. Okay, so they thought about it and joined. Okay, all right, and that's how you would do your interpretation.